Hi, fifth graders. So today you guys are going to be doing some finish up work for science. We're trying to get our science unit done on Friday and we'll make our salad dressing on Monday. So I'm going to be collecting your science journals on Friday. We've got to finish up some pages that we didn't get finished with when we read the book Science You Can't See. So you guys can work in pairs or groups of 3, or you can work by yourself. And you're going to use the book to do pages 38 and 39. And in those pages, you're going to be asked to make some inferences based on what you've read, and then use some evidence too to back up your inferences. So let me show you those pages right here. I'm going to switch this over. Okay, so this is pages 38 and 39. Okay, and right up here, like this first one, Karen Chin is investigating the question, how and what did dinosaurs eat? What evidence did she use to help answer her question? So she used a few pieces of evidence, but there was one very, very big piece of evidence that she used to find out information about what dinosaurs ate. So you'll be writing the answer there, and then what inferences did she make based on that evidence? So based on studying that piece of evidence, what inferences did she make about what dinosaurs eat? Because people weren't around when dinosaurs were around. And then it goes on for a couple questions about how deep is the ocean floor. And we read that section of the book last week. And then the Farid El-Gabali, who has the magnetic atoms microscope, inferences about that. And then the last part, you just choose a section to reread and record an inference you made while reading. So something that the book doesn't tell you outright, but that you have made a guess of based on the evidence that's there. So that, let me put this back. That's the first part. And then the second part of your work today is to do pages 40 through 42. On page 40, you're just answering the question in a complete sentence. What happens to the molecules of 2 liquids when you mix them together? So it gives you a big space on this page too to draw a picture if you want to draw a picture. And this can be any 2 liquids. And we talked about this a little bit last week. And then you're going to move on to using the simulation again. And this is going to feel a little bit repetitive because we're not using the emulsifier mode yet. We're still using the solubility mode. But this time we're really going to focus on not how attracted the molecules are to one another, but how attracted they are to themselves. And we're going to start thinking about how a mixture separates because of that attraction. So I'm going to switch the camera again. So here's that one page. This is page 40. So you can see it's a pretty short little question, but then you have a big space where you can draw a picture, draw a model of what molecules are doing when 2 liquids are mixed together. And then this has all the directions, but it's pretty much the same one that we did earlier last week, where you go to the sim and you're picking a molecule. Like here it's 3 and 4. Right here, you're recording the attraction that the molecule 3 has to molecule 4. And then here you're recording the attraction that it has to itself, and here the attraction that molecule 4 has to itself. Then you circle how mixed it ends up being after you stir it, And then you write down how, like, your observations. So your evidence is your observations. So did you have molecules attaching to each other? Did you have, and which ones were doing that? Were they attaching to each other and staying attached, or were the other ones bumping them apart? Like, what was happening there? Okay? And so remember, when you go to amplify, you are going to clever, and then you're logging in. And then you're going to amplify. And then you're going to go on to the sim. So, of course, I'm getting the load thing. Remember, mine's a little different, so I have to do this little step first because I have the special teacher version. And then you're going to have modeling matter. And remember, it's this menu right up here. Yours doesn't look like that because mine's the special one. And you're going to go to that tools. And then it is another thing. And then it's right here. This modeling matter sim, okay? And that's where you're gonna be doing this. And you're only going to be looking at the solubility mode here. If you have time, you can check out the emulsifier mode, especially since we just did the emulsifier experiment yesterday. But like here, you would pick 3 and put it in there, and 4 and put it, oh, come on, 4 and put it in. Okay, one more time. 4 and put it in there. Okay, hang on. There we go. Look, it happened that time. And remember, you're looking for your attraction here and your attraction to each other or to themselves. And then when you zoom in, you want to stir. That's your reload. Here's your stir. Got it. And you're going to stir. Okay? And you can always play it back and pause it. All right. So you'll be doing this page and this page. So you have lots. You get to select them this time. And you're trying to select the ones that show high attraction to themselves. And then you've got 2 questions. What happens when molecules have high level of attraction to themselves? And when 2 substances are completely mixed, what level of attraction do their molecules have to one another and to themselves? Okay, so complete sentences there. And that will bring us right to the page we just did with the stability test. So then we'll be all caught up. Okay. So I want you to do really good work today, and I will see you on Wednesday, and we'll finish up our unit on modeling matter.